Welcome to Power Electronics lecture series. In this tutorial, we are going to discuss about triggering methods. Coming to learning objectives, after completing this tutorial, you will be able to know definition of triggering, different types of triggering methods, reliable method for all practical applications. Coming to definition of triggering, the process of turning on the SCR is known as triggering. When anode is positive and cathode is negative, that is this one, anode is positive and cathode is negative, here junctions J1 and J3 are in forward bias. J1 and J3 are in forward bias, which are act as a short circuit, and junction J2 is in reverse bias, which is act as a open circuit. Here this junction act as a open circuit. This concept we have already discussed in working of SCR. If you want to know the working of SCR, find the link which is in description. Due to this reverse biased junction J2, there is no flowing of current from anode to cathode, and SCR act as a off switch. By using following methods, we are going to make the reverse bias junction J2 into forward bias. If junction J2 is in forward bias means SCR starts conducting. Coming to types of triggering methods, these are mainly classified into 5 types. Those are, first one is the forward voltage triggering, then light or radiation triggering, third one is the temperature or thermal triggering, fourth one is the dV by dt triggering, and fifth one is gate triggering. Again, gate triggering classified into 3 types. Those are DC gate triggering, AC gate triggering, and pulse gate triggering. By using these methods, we are going to make the reverse biased junction J2 into forward bias, and we are going to make the SCR into conducting state. Coming to first method, that is forward voltage triggering method. Okay, here anode is positive and cathode is negative. So junctions J1 and J3 are in forward bias, junction J2 is in reverse bias. By using this method, we are going to decrease the width of junction J2, then we are going to make this junction into forward bias. Then SCR starts conducting. Okay, here in this method, we are going to increase the voltage between anode and cathode. Okay, by increasing the voltage between anode and cathode at particular voltage, the width of junction J2 is going to decrease. At particular voltage, the width of junction J2 is decreases, and finally it comes into forward bias. It comes into forward bias and act as a short circuit. So all the junctions, that is junction J1 and J3 already are in forward bias. Here, by gradually increasing the voltage between anode and cathode, junction J2 also comes into forward bias. So all the 3 junctions are in forward bias. So there is a possibility of current which is flowing from anode to cathode. So SCR comes from forward blocking mode to forward conducting mode, and it starts conducting. This is about forward voltage triggering. Coming to second method, that is light or radiation triggering. This is very simple. That is, in this method, we are going to inject the high energy particles at the junction J2. This is our junction J2. Okay, we are going to inject the high energy particles, those are electrons and photons, at junction J2. By injecting these high energy particles, the width of junction J2 is going to decrease, and finally it comes into forward bias. Okay, that is, by injecting the high energy particles like electrons and photons, the width of junction J2 is decreases. If width is decreases, it comes into forward bias. If junction J2 comes into forward bias means SCR comes from forward blocking mode to forward conducting mode, and it starts conducting. That is about the second method, that is light or radiation triggering. Coming to third method, that is temperature or thermal triggering. The concept of this method is very simple. Whenever anode is positive and cathode is negative, junctions J1 and J3 are in forward bias, which are act as a short circuit. And junction J2 is in reverse bias, which is act as a open circuit. Due to the open circuit condition of junction J2, total applied voltage is going to appear across the junction J2. Okay, due to this applied voltage, the temperature of junction J2 is going to increase. If we further increase the voltage, the junction temperature also further increases. By increasing the magnitude of applied voltage, the temperature of this junction J2 is increases, and at particular value of junction temperature, the width of junction J2 is decreases, and finally junction J2 comes into forward bias. If junction J2 comes into forward bias means SCR starts conducting. This is the concept of temperature or thermal triggering. Coming to fourth one, that is dV by dt triggering. Whenever anode is positive and cathode is negative, junctions J1 and J3 are in forward bias, which are act as a short circuit, and junction J2 is in reverse bias, which is act as a open circuit. And this reverse biased junction J2 having the characteristics of capacitance, and we know properties of capacitance. Capacitance does not allow sudden changes in voltage. Consider small parameters for analyzing dV by dt triggering. That is, let Cj be the junction capacitance. Q is the charges across junction J2. Ic is the charging current. Similarly, V is the junction voltage. Now, by using these parameters, we are going to derive small formula. Depending upon that formula, we are going to define the dV by dt triggering. We know formula for capacitance C, that is C is equal to Q by V. We are considering junction parameters, so consider Cj. Junction capacitance Cj is equal to Q by V. From that, consider Q value, that is Q is equal to V into Cj. We know formula for current, that is current is nothing but rate of change of charge. So consider charging current Ic is equal to rate of change of charge, that is nothing but dq by dt. Now in place of Q, substitute this value, that is V into Cj, and apply the differentiation. By applying differentiation, we are going to get V into dCj by dt plus Cj into dV by dt. Here Cj, junction capacitance is the constant. The derivative of constant value is 0. So this entire term becomes the 0. Then finally we are getting Ic, charging current Ic is equal to Cj into dV by dt. Okay, from this expression we are going to conclude that dV by dt triggering, that is, by increasing the dV by dt rating, we are going to increase the charging current. Means the current flowing through anode to cathode is increases. Means SCR comes from forward blocking mode to forward conducting mode, and it is in conducting mode. Means there is a flowing of current from anode to cathode. So we can conclude that SCR is in conducting mode. This is about the dV by dt triggering. Coming to fifth method, that is gate triggering. Okay, in this method, by using some external voltage at gate terminal, we are going to turn on the SCR. Gate triggering is nothing but by using some external voltage source at gate terminal, we are going to turn on the SCR. Now, depending upon the external source, depending upon the type of the external source, gate triggering method is classified into three types. Those are, first one is the DC gate triggering, second one is the AC gate triggering, and third one is the pulse gate triggering. Now we are going to discuss about these types of triggering methods. Coming to DC gate triggering, in this method, by using some DC voltage source, at gate terminal, we are going to turn on the SCR. In this, we are having some disadvantage, that is, in this method there is no isolation between the power circuit as well as gate circuit. Here power circuit is nothing but the circuit which is consisting of anode and cathode is nothing but power circuit, and circuit which is consisting of gate and cathode is nothing but gate circuit. Okay, in DC gate triggering, there is no isolation between these two circuits, means there is no isolation, means SCR may get damaged. Okay, that is the disadvantage of DC gate triggering. Coming to second type of gate triggering, that is AC gate triggering. The disadvantage in DC gate triggering can be overcome by using AC gate triggering. In this, by using the isolation transformer at the gate terminal, we are going to turn on the SCR. In this, we are going to use the isolation transformer, means the cost of the transformer is more. So the disadvantage of AC gate triggering is cost is more. So we are going to consider the third type of gate triggering, that is pulse gate triggering. In this method, we are going to apply the pulses at regular time intervals at the gate terminal. Then we are going to turn on the SCR. Okay, this is one of the reliable method, and in all practical applications we are going to use this type of triggering. This is about the different types of gate triggerings.